Monday. So for today we're going to skip over lesson 3 from unit 5 and we're going to do lesson 4, okay? That's just in the interest of saving time and focusing on what we absolutely need to. For some reason, I kind of had a moment when I printed this out and I didn't include the first page. So we're going to start off with an example. I am still doing this from eMathInstruction, but I kind of broke it up, writing steps for you. This looks like a lot, but if you print this out and you have it on hand when you do these problems, it will be really helpful. Okay, so today we're going to learn the other algebraic way, or method, sorry, to solve a system of equations, and that's called elimination. Okay, so this is the method of elimination. The goal for elimination is, as the name suggests, we want to eliminate one of the variables. So the idea is you want one of the variables to have the same coefficient. One of them is positive and one of them is negative, because that way when we add them together, they'll cancel out or eliminate. So if you look at my example here, this is what our goal is. We want to have one of these variables that has the same exact coefficient, the number is the same, one of them is negative, one of them is positive, because when I add these together, it's going to cancel out. What that does is it leaves me with just one variable that I can actually solve for, because right now I don't know how to solve this monstrosity, right? So here's the steps. I'm going to talk you through it first, and then we're going to follow along with the steps to actually solve this system of equations. So the first step is that you want to make sure your equations are lined up from the top to bottom by like terms. So what I mean by that is they're already going to be lined up. Make sure the x's are in the same spot and the y's and the constants are all in the same spot. If they're not, you want to line them up. Step 2, we want to look for any variables that already have the same coefficients. If they're already one positive and one negative, you can add right away. So for example, these variables both have a coefficient of 4. One of them's negative and one of them's positive. So I don't have to do anything here. I'm just going to be able to add. The problem is we're not always going to have what we need. So if you don't have what you need, you're going to multiply the equations by something so that you do have this situation. So for example, pretend like these 4's aren't here. If I have this 8 and this negative 2, I would be trying to figure out how I could get the same number here. So I know that I could multiply 2 by 4 here, and I would get negative 8. So that's what I mean by that. And I'll walk you through that, so don't worry. So our next step is to add straight up and down in order to cancel that one variable. So we can do that here because this is already set up. I'm going to rewrite it here. Negative 4x minus 2y equals negative 12, and then we had a positive 4x plus 8y equals negative 24. So to eliminate, we add straight up and down like this. Negative 4 plus 4x, that cancels out. That's what I want. That's my whole goal here. Now I'm going to do negative 2 plus 8y, which gives me 6y. Bring the equal sign down, and now we add negative 12 and negative 24. And remember, you guys can use your calculators at all times. That gives me negative 36. Our next step is to completely solve for the variable that's left. So that means I have the y left over. Now I only have a nice one-step equation. I can solve this easily. So I'm going to divide both sides by 6, and I'm finding that y is equal to negative 6. Hooray! Remember that when we solve a system of equations, our solution is supposed to be written x comma y, right? So this gives me the y, but I don't have the x. So just like we did with substitution, now that we have a value for this variable, we're going to pick the easier equation and plug it in to find the other variable. So whichever one you think looks nicer. Okay, even though these are negatives, we can use that because the numbers are smaller. It's up to you though. So I'm going to use that first equation, negative 4x minus 2y equals negative 12, and I'm just going to replace the y with negative 6 so I can find x. Okay, so that's going to give me negative 4x minus 2 times negative 6 is equal to negative 12. Okay, so this is negative 4x. This becomes a positive 12 is equal to negative 12. So now I have to solve for x. And this is minus 12 on both sides. Negative 4x equals, this will be negative 24. And now I just have to divide by -4 on both sides. And x will give me +6. Okay, so now we have an x of 6 and a y of -6. And our final step is to write our answer as a point x comma y. So remember, that's how you write the solution to a system of equations. X is 6, y is -6. So the solution is 6 comma -6. That's how we do it. Let's look at one where we have to change something. Okay, I lied. We're gonna look at one that you can eliminate automatically first, and then the next one will have to change, okay? So quickly, I look here, my variables are lined up, x's, y's, and then the constant. Next, I look and see, do I have the same coefficient here? No, I don't. But if you look here, I have a -y and a +y. Those are gonna cancel out. So I can just go right ahead and start with adding. So I'm just gonna rewrite, you know, I like to rewrite things. Okay, and I'm gonna add straight up and down. So this cancels out. 2x plus x gives me 3x. This is gone now. And then 11 plus 19 gives me 30. Now I divide by 3 on both sides. I'm solving for x. How easy. X is going to be 10. Okay? So I know one part of my solution. Now I'm going to take the easier equation, which in this case is definitely the first one. X minus y equals 11. I'm going to plug this 10 in for the x so I can find 11. I'm sorry, so I can find y. So 10 minus y equals 11. I'm solving for y. Subtract 10 from both sides. I get -y equals 1. And now remember, if you have a negative here, this is just like multiplying by -1. You can divide by -1, and y is equal to -1. Okay, so now I have my x and my y. And as a solution, that would be written as 10, comma, -1. Hooray! Now this question here is going to be the first example where you see we have to actually change something. Now, there's two options here. We can eliminate the x, or we could eliminate the y. You have to look and see, what could I multiply x by so that this would cancel out? So this is a -4. I would need the x on the bottom to be a +4. So what I can do is I can multiply this whole equation by 4. So in order to manipulate like this, you have to multiply the whole equation. Now you also could have multiplied the second equation by 3, because that would give us -9, which would cancel out. Okay, so I'm going to rewrite this equation, the system. The top was -4x plus 9y equals 9. Now I'm going to multiply my second equation by 4. That gives me 4x. Then the -3y times 4 is going to give me -12y. And then -6 times 4 gives me -24. And now I just follow the same steps I've been doing all along. So I'm going to add them straight up and down so I can cancel that out. Goodbye. -12 plus 9y gives me -3y. And then -24 plus 9 is going to give me -12. -15, not 12. Sorry guys, can't think straight right now. Okay, and now we're going to divide both sides by -3. And y is equal to +5. That's the first part of our solution. So now we go back and pick one of these to substitute in for. Let's use the second one. It was x minus 3y equals -6. And we're going to replace the y with 5. So this is going to be x minus 3 times 5 equals -6. So that's x minus 15 equals -6. We want to solve for x, so we add 15 to both sides. And x is equal to 15 minus 6, which is 9. So I have my x and my y. My solution will be 9, 5. Okay, guys, and that's how we do it. So now taking a look at the lesson that's in eMathInstruction. The first example, Kirk is showing us the same exact system, solving one by eliminating x, and then solving it again by eliminating y, okay? So what I want you guys to do is I want you to pause it, and I want you to try it. And when you unpause, you will see the solution. So go ahead, pause it, and give these a try. Okay, guys, so once you solved this, hopefully you got, in both cases, that the solution would be -2, 4. So what you can do in the first one is you're trying to eliminate x, so you want this -2x to be a -4 so we can get rid of this. So all you have to do is multiply that by 2 to get -4. So just remember to multiply the whole equation by 2. So it turns into -4x plus 2y equals 16. And when you solve that, you get y is equal to 4.
Why is it so foggy outside?
And then we plug that back in, Mommy, and we find
why
x.
Is it so foggy?
And we find x is -2.
Why is it so foggy?
And for part B, he asks you to eliminate y. So you have to think to yourself, I need to be able to eliminate 5y. So I need the bottom one to be -5y. So luckily this is just a plain old y, so you can multiply it by anything you want. Multiply the whole bottom equation by -5. And you end up with 10x minus 5y equals -40. Add it all up, you get x is -2. And when you substitute it, you find that y is 4 again, okay? You don't have to do part C. Okay, we're gonna just do exercise 2 because this is showing you an example where you can't just take one of the variables and multiply it by something. This is one of the examples where you have to multiply them both by something. Okay, so if you look at it, I can't eliminate x by just multiplying 2 by something to get 5. And I can't multiply y by just multiplying this by something to get 7. So what I have to do is pick a variable. And generally what I do is I look for where it's already negative and positive, because then I don't have to multiply by a negative. And I'm going to think of what is the least common multiple of 7 and 2, which is going to be 14. So I'm going to multiply my top equation by 7 and my bottom equation by 2. And then that'll give me 14 in the middle. And then I can cancel those out. So watch what happens. The top equation is going to turn into 35x minus 14y is equal to 70. Okay, and the bottom equation, we're multiplying by 2. That's going to turn into 4x plus 14y is equal to 86. Okay, and again, I'm just multiplying each piece by 2 and up top each piece by 7. And now, look, I have a -14 and a +14, so I'm going to be able to cancel it out. Goodbye. So now this becomes 39x is equal to 70 plus 86, which is going to give me 156. Okay, and now I'm going to take this and I'm going to solve for x. So what I'm going to do is, since this is the last problem, we're going to pause it. I want you guys to finish solving. I wanted to just show you how to do this part. Finish solving and all the way down to getting the solution, and then unpause and you can see your answer. Okay, so if you finish solving this, you'll find x is equal to 4 when you divide both sides by 39. Then you pick one of the equations. I picked the second one. You could have also done the first one, whichever one you want, doesn't matter. Plug in 4 for x and you find that y is 5. So your final solution is 4, 5. Okay guys, I know this can be a very tricky topic, so if you're still struggling with it, you can watch Kirk's video, you can watch the Khan Academy video. Khan Academy one's pretty good. And you can also do some extra IXL to walk you through some of these problems. Okay guys, don't forget to leave a comment if you need any help. And also, we will be doing our Google Meets on Wednesday. I'm thinking 12 o'clock, so if anyone has any problem with 12 o'clock, just let me know and we'll figure out a better time. Okay guys, have fun.